of katakoda kubernetes practical series. The third one is deploy guestbook with example. This scenario teaches you how to deploy the guestbook example using kubernetes. I'm going to start the scenario. uh, this scenario explains how to launch a simple multi-tier web application using kubernetes and docker. The guestbook example application stores notes from guests in Redis via JavaScript API calls. Redis contain a master for storage and replicated set of Redis slaves. Core concept. These are the core concepts. The following core concepts will be covered during this scenario. These are the foundations of understand Kubernetes: pods, replication controllers, services, node ports. I'm going to start the scenario. Step 1, start Kubernetes. To start, we need running Kubernetes cluster. The details of this are explained in the launch Kubernetes cluster scenario. Start single node cluster using the helper script. The helper script will launch API master proxy and DNS discovery. The web apps uses DNS Wizard to find the Redis slave to store data. Health check. Check everything is up using the following health check. Mm, Continue. Step 2, Redis master controller. The first stage of launching the application is to start the Redis master. A Kubernetes service deployment has at least two parts: a replication control and a service. The replication controllers defines how many instances should be running, the Docker image to use, and a name to identify the services. Additional options can be utilized for configuration and discovery. Use the editor above to view the YML definition. If Redis were to go down, the replication controller would restart in on an active node. Create replication controller. In this example, YML definition Redis server called Redis master using the official Redis running ports 6379. The kubetic create command takes a YAML definition and instructs the master to start the controller. What's running? Uh, the above command created a replication controller. The replication name desired current age. All containers described as pods. A pod is a collection of containers that makes up a particular application. For example, Redis. You can view this using kubernetes. Kubernetes pods. If you are interested in what's launching, then you can still use Docker client like before. Redis master. The third step is Redis master service. The second part is service. Kubernetes service is named load balancer that provides traffic to one or more containers. The proxy works even if the containers are on different nodes. Services proxy communicate within the cluster and rarely expose ports to an outside interface. When you launch a service, it look like you cannot connecting using curl or netcat unless you start it as a part of Kubernetes. The recommended approach is to have a load balancer service to handle external communications. Create service. The YAML defines the name of the replication controller, Redis master, and the ports which should be proxied. Create. List and describe services. Kubernetes describe services. Describe master. Replication slave. In this example, we'll be running a Redis slave which will have replicated data from the master. More details of Redis slave can be found at uh, as previous described the controller definition. How the service run in this example, we need to determine how it discovers the other pods. The YAML represents the GTL. You can change its you can change it to use environment variables in the YAML, but introduces creation order dependencies as the service needs to be running for the environment variable to defined. Start ready slave controller. In this case, we'll be launching two instances of the pod using the image Kubernetes. List replication controller. Step 5 is ready slave service. As before, we need to make our slaves accessible to incoming requests. This is done by starting a service which knows how to communicate with ready slave. Because we have to replicate pods, the service will also provide load balancing between the two nodes. Shorten replicated pods with the date started. We can now deploy the web application. The pattern of deploying web application is the same as the we have deployed before. Launch front end. The YAML defines a service called front end that use the image controller will always exist. List of control pods. PHP code. The PHP code use HTTP and JSON to communicate with Redis. When setting a value, request go to Redis master while read data forms nodes. Guestbook fronted services. To make the fronted accessible, we need to start the service configure the proxy. Start proxy. The YAML defines the service as a node port allows you to set well-known ports that are shared across you enter class. This is like in this case we define our web apps is running on port 80, but we'll expose the service on Kubernetes get services. Access guestbook front end. Step 8. With all controller and services defined, Kubernetes will start launching them as pods, and a pod can have different states depending on what comes. Pending state, it is not able to launch once ready. The status will change to run. Yield strip using following command. Assign a developer port randomly. You can find the assign mode in Kubernetes. Weave user interface. Once the pod is running state, you will be able to weave page. This is the URL page. Under covers, the PHP service is discovering the Redis via DNS. You now have working multi-tier application deployed on Kubernetes. The casebook. You now have working multi-tier application deployed on Kubernetes and Docker. In this scenario, we introduced the core concepts of Kubernetes. We explain how replication controller define how a container should be run. The service is used to determine how to proxy traffic to the controller. Finally, everything is run as a pods. Once running, the service can be accessed via the defined node port. And that's the end of third scenario. Then moving to a fourth one. Uh, the fourth one is deploy containers using Kubernetes. kubectl. Learn how to use kubectl to launch containers and make them accessible. Then I'm going to start this fourth practical. It's a fourth scenario. Uh, in this scenario, you will learn how use kubectl to create and launch, develop deployments, replication controllers, and expose them via services without writing YAML definitions. This allows you to quickly launch containers onto the cluster. Step one, launch cluster. To start, uh, we need to launch Kubernetes cluster. Execute the command below. Start the cluster if serial. Kubectl run. The run command creates deployment based on the parameters specified, such as image or replicas. This deployment is issued to Kubernetes master, which launches the pods and containers required. Kubectl run is similar to Docker run, but at a cluster level. The format the format of the command is kubectl run name. The following command will launch deployment called HTTP, which will start container based on the Docker. You can then use kubectl to view the status of the deployments. To find that uh, to find out what Kubernetes created, you can describe the deployment process. Kubectl described the deployment HTTP. By that command, HTTP namespace. The description includes how many replicas are available, labels specified, and the events associated with the deployment. These events will highlight any problems and errors that might have occurred. In the next step, we'll expose the running service. Kubectl expose, that's the third step. With the development tech created, we can use Kubernetes to create a service which expose the pods on a particular ports. Expose the newly deployed HTTP deployment via Kubectl. Expose the command allows you to define the different parameters of the service and how to expose the deployment. Use the following command to expose container. Kubectl expose deployment HTTP. Mm, mm, mm. You will be able to ping the host and see the result from HTTP service. Kubectl run and expose. With the kubectl run and possible to create the deployment and expose it as a single command. Task use the command to create a second HTTP service exposed on port 8001 and HTTP exposed by this command. You should be able to access it using this HTTP this command. Under the covers, this exposed port as a result, you will not see the service listed using this. To find the details, you can use this command. Running the above command, you will notice the ports are exposed on the pod, not the HTTP container itself. The post container is responsible for defining the network for the pod. Other containers in the pod use share the same network namespace. This improves network performance and allows the containers to communicate over the same network interface. Step 5 is scale containers. With our deployment running, we can now use kubectl to scale the number of replicas. Scaling the deployment will request Kubernetes to launch additional pods. These pods will then automatically be load balanced using the exposed services. Uh, the command kubectl scale allows us to adjust the of pods running for a particular deployment or replication controller. Listing all the pods, you should see 3 running for the HTTP deployment. Once each pod starts, it will be added to the load balancer service. By describing the service, you can view the endpoint and the associated pods which are included. Making request to the service will request in different nodes browsing the request. That's the end of fourth scenario. The fifth one is deploy containers using YAML. Here we learn how to use YAML definitions to deploy containers. Going to start that scenario. In this scenario, you will learn how to use Kubectl to create and launch deployments, replication controllers, and expose them via service by writing YAML definitions. YAML definitions defines the Kubernetes objects that become scheduled for deployment. The objects can be uploaded and redeployed to the cluster to change the configuration. Uh, Step 1. Create deployment. One of the most common Kubernetes object is the deployment object. The deployment object defines the container spec required, along with the name and labels used by other parts of Kubernetes to discover and connect to the application. Copy the following definition to the editor. The definition defines to launch application called using Docker. Mhm. This is deployed to the cluster with the command as it is deployment uh, object. The list of all the deployed objects can be obtained via this command. Details of individual deployments can be outputted with the second step is create service. Kubernetes has powerful networking capabilities that control how applications communicate. These networking configurations can also be controlled via YAML. Copy the service definition to the editor. The service selects all applications with the label web app1 as multiple application points and the default will be balanced based on this common label. The service makes the application available via node port. All Kubernetes objects are deployed in consistent way using Kubectl to deploy the service with as before. Details of all the service objects deployed with by describing object. It is possible to discover more details about the configuration. Scale deployment details of the YAML can be changed as different configurations are deployed to be deployed. This follows an infrastructure as a code mindset. The main fists should be kept under source central and used to ensure that the configuration is production matches the configuration in source control. Mm, Update the deployment .yml file to create increase the number of instances running. For example, the file should look like this. Updates to existing definitions are applied using Kubectl apply to scale the number of replicas. Deploy the updated YAML files using Instantly, this desired state of our cluster has been updated. Get deployment. Additional pods will be scheduled to match the request. As all the pods have the same label sector, they will be load balanced behind the service node pod deployed. Issuing request to the pod will reduce in different containers processing the request. Additional Kubernetes networking details and object definitions will be covered future scenarios. That's the end of fourth scenario. Oh, that's the fifth one. That's the end of fifth scenario. Uh, then our next practical is our sixth scenario, that is creating increase ingress routing. Create ingress routing. In here, we're going to learn how to define host and path-based ingress routing. And going to start sixth scenario. Uh, Kubernetes have advanced networking capabilities that allow pods and services to communicate inside the cluster's network. And ingress enables inbound connections to use to the cluster, allowing external traffic to reach the correct pod. Ingress enables externally reachable URLs, load balance traffic, terminate SSL, name-based virtual hosting for Kubernetes cluster. In this scenario, you will learn how to deploy and configure tools to manage incoming HTTP requests. The first step is create and deployment. To start, deploy an example HTTP service that will be the target of our request. The deployment contains three deployment, one called web app 1, and the second called web app 2, and the third called web app 3, with a service for each. Step one is create deployment. To deploy an example HTTP server that will be target. Okay, okay. Task deploy the definitions with and the status can be viewed with step 2 deploy ingress. Ingress is deployed as a replication controller. This controller combines a software load balancer such as Nginx or HA proxy with Kubernetes integration for configuration itself based on the defined rules. The YAML files below defines the Nginx-based ingress controller together with the service, making it available on port 80 to external connections using external. This cluster was running on cloud provider, then it would use load balancer service type. The ingress controllers are deployed in a familiar fashion to other Kubernetes objects with the status can be identified using step 3 deploy ingress rules. Ingress are an object type with Kubernetes. The rules can be based on request, host domain, or the path of the request, or combination of both. As an example, set of rules are defined within the important part of the rules are defined below. The rule apply to request for the host. Two rules based on the path request with single catch all definition. Requests to the path web app 1 are forwarded on to the service web app 1 SVC lives. This request to rules are used. This demonstrates how an application's URL structure can behave independently about how the applications are deployed. As with all Kubernetes objects, they can be deployed via once deployed, the status of all the ingress rules can be discovered via test. The step 4 is test. With the ingress rules applied, the traffic will be routed to the defined place. This first request will be processed by web app 1 deployment. The second request will be processed by the web app 2 deployment. Finally, all other requests will be processed by web app 3 deployment. And that's the end of sixth scenario.